Hello students, welcome to today's lesson. We are still discussing regression and we are exploring more of examples. So today we are going to look at an example 2 whereby the following regression equation was obtained from correlation table. So we get a regression equation of y is equal to 0.516x plus 33.73. And this other one, which is x is equal to 0.512y plus 32.52. So this is regression of y on x, and this is regression of x on y. So therefore, we need to get the relation, the regression relation R. To do that, we are going to differentiate y with respect to x in the first equation, this equation here. If we take the derivative of y with respect to x, we get 0.516. And for this second equation, the differential of x with respect to y gives us 0.512. Remember, the derivative of a constant is 0. So this is 0. So the derivative of y leaves us with 0.512. Then, in order to find R, the product of dx dy and dy dx is equal to R squared from this formula here. Therefore, we can take the square root of both sides to remain with R. And if we multiply 0.516 by 0.512 and we take the square root, we are left with 0.513. Therefore, this is the correlation relating these two regression equations. Therefore, it is very important that we define the correlation coefficient mean of this variable x and y. So in order to get the correlation coefficient mean of x and y, we are going to use this formula. We will let x, this equation is just the same equation we had here, and x is the same equation we have here. I've just transferred them to here. And now we can let y bar to mean the mean, the correlation coefficient mean in the y equation to be equal to 0.516 x bar. Now it is not x. We call it x bar plus 33.76. And for the second equation, the correlation coefficient mean in the x bar is equal to 0.512 y bar. And now it is not just y, but it is y bar plus 32.53. Therefore, we can substitute because we have x bar, the subject of the formula here, and we have x bar in this other first equation. We can call this equation 1 and this is equation 2. And as you can see, x bar is that, and we have x bar here. So if we substitute this equation 2 into equation 1, we are left with x bar. No, we substitute equation 1 into equation 2. We are left with x bar is equal to 0.512 in bracket y bar. Y bar is the whole of this term here. So 0.516x plus 33.76 plus 32.53. If we simplify, we get x bar is equal to 0.2641x bar plus 17.23 plus 32.52. And we can now collect the like terms. The x bar and x bar, if we bring this x bar this other side, it becomes minus. So x bar minus 0.2641 x bar will give us 0.7359 x bar is equal to this plus this give us 49.79, and we divide through by 0.7359. So x bar is 67.67. And therefore, if we have x bar as this, we can substitute it in equation 2, whereby in equation 1, whereby we have y bar is equal to 0.516 in bracket x bar, and x bar is 67.67 plus 33.73. This gives us 68.67. And this is how we can make the correlation coefficient mean of the unknown variables x and y. Let's look another third example. You are asked to find the regression line of x on y for the following data. Hence, estimate the value of y on x is equal to 10. So the data we are referring to is x has a data set ranging from 1, 3, 4, 6, 8, 9, 11, 14, and that of y is 1, 2, 4, 4, 5, 7, 8, 9. Therefore, this formula will be our guided line. Y is equal to a plus bx, and a and b are the constants of the correlation, given that the sum of y is equal to n times a plus b times the sum of x. So this is our equation 1, and the sum of x, y is equal to a times the sum of x plus b times the sum of x squared. This becomes our equation 2. Therefore, how do we get these unknown parameters? Remember, what we know from the table are the values of x and the values of y. But we don't know yet the values of the product of x and y, and the values of x squared, as well as those of y squared. And we can get it directly by counting 1, 2, 3, 4, 5, 6, 7, 8, and n is 8 to mean the total data, the total item in the table sample. So therefore, we can construct the table this way: x, y, x squared, y squared, the product of x and y. So we are just rewriting the values of x in column wise, the values of y in column wise. Then we square x. 1 times 1 is 1, 3 squared is 9, 4 squared is 16. So we fill the entire row that way, and at the end here we add 1 plus 9 plus 16 plus 36 plus 64 plus 81 plus 121 plus 196, and we get 524. Here as well, we square the y column. 1 squared is 1, 2 squared is 4, 4 squared is 16, and we repeat the same process. Then we add all of them, we get 256. And on this other column, it is the product of x times y. 1 times 1 is 1, 3 times 2 is 6, 4 times 4 is 16. We fill in this entire column, and if we add them, we get 364. Therefore, we need to employ the formula 1, whereby we have the sum of y is equal to na plus b summation of x. What is summation of x? The total sum of x is 56. Then we can replace it here. So the sum of y, which is 40 actually, is equal to na plus 56b. And the summation of xy, already we have it here as 364, is equal to 56. Summation of x is 56a plus b summation of x squared. The sum of x squared is 524b. So therefore, you realize that this equation here and this give us two set of equations. Two set of linear equations. So 40 is equal to 8a plus 556b, and 364 is equal to 56a plus 524b. Then we need to solve for the value of B. In order to do that, we can use elimination method or substitution method. But for simplicity, I'll do the elimination method. In the elimination method, I want to, in the first equation here, what if I multiply by 8 will give me 56? That is 7. So I multiply the entire thing in the entire row of the first equation by 7. So if I do that, I get 280 is equal to 56a plus 392b. And I rewrite the lower equation as 364 is equal to 56a plus 524b. Then now I can subtract out to eliminate a. 56a minus 56a is 0. 392b minus 524b is negative 132b. 280 minus 364 gives negative 84. Then I can now divide through by negative 132 to remain with b. And if I do that, I get 7 over 11. Now that I know the value of b, I can use this first equation here to solve for a. And to do that, I make a the subject of the formula by taking 56b, crossing the equal sign, it becomes minus 56 times the value of b. b is 7 over 11, in decimal it is 0.636. So if I solve this, I